Hi guys, so today we will be talking about the states of matter. So, I'm sure that you all remember from some previous science class the three states of matter. We can also call these the three phases of matter. Okay, we know that they are solid, liquid, and gas. So, a couple of things that I want to mention before we get into the lesson. So, in this unit, we're going to be going a little bit deeper than just what are the three states of matter. We are going to be paying attention to the behavior of the particles of substances in each of the three phases. So, as you work through this lesson, I want you to be thinking about the particles of the substances. That is the most important piece for this standard. Second thing that I want us to note before we start is kinetic energy. So we're not going to go into detail here, but in order to be successful on this standard, you need to know what kinetic energy is. So all you need to know is that kinetic energy is the type of energy related to motion. So things that are moving have kinetic energy. If things are moving faster at higher rates of speed, they have more kinetic energy than things that are moving at lower rates.
Other form of energy that you should be familiar with regarding the states of matter is thermal energy. Thermal energy is the energy associated with heat or temperature. So substances that have lower thermal energy are at lower temperatures, and substances that have higher thermal energy are at higher temperatures. As we can see over here in the diagram, as we move from solid to liquid to gas, the temperature and therefore the thermal energy of the substance increases. Starting with solids, we can see that solids are very cold, therefore have very low thermal energy. Liquids are somewhere in the middle, so they have a medium amount of thermal energy and have somewhere in the moderate range of temperature. As we move to the gaseous phase, we have a very high temperature and very high amounts of thermal energy.
Of speed. So now we're going to look at all three of the states of matter and how their particles are arranged and how they behave. So our first state of matter is solid. So like the table you're sitting on, the computer that you're looking at, all solids. So the first thing we're going to look at is the shape. So solids, if you think about how a solid behaves, it has a fixed shape. If you pick up a cube, it's going to stay a cube. It's not going to change shape. It has a fixed or a rigid shape that doesn't change. Its particles, if you look here in the diagram, are arranged in an organized pattern. So if we were able to zoom in and see all of the atoms or molecules in a solid, you would see that all of those particles were perfectly arranged in an organized pattern. The volume of a solid is also fixed. So if we think again, if I pick up a cube, it's not going to spread out and take on a larger volume. It's also not going to shrink and take on a smaller volume. It is fixed at the volume that it is. Now it's particle spacing. So if you look again, let this visual be your guide. The particles in a solid are very, very, very close together. So you can see they are almost not separated at all. And their motion, so the particles in any substance, even if you cannot see it, the particles inside of the substance are moving. In a solid, they are moving, but it is simply a vibration. So they are staying in the same organized pattern, they're staying at the same separation from one another, but they are vibrating in place. Their particle speed is very slow, right? So they are vibrating, but they're not moving far and they're not moving at a very high speed. And if we think back to what we said about kinetic energy, because they're not moving very far and they're moving at a very slow speed, the kinetic energy of the particles in a solid substance is very low. The next state of matter is a liquid. So a liquid, if you think about a cup of water, does not have a fixed shape. Liquid substances will take the shape of whatever container you pour them in. So if I spill a cup of water on the floor, it's not going to stay in the same shape as the cup I had it in. It is going to spread out until it is all spread across the floor. As you see in the visual, the particles in a liquid are less clearly organized. They are in less of an organized pattern, and they are organized in a more random fashion. Their volume, however, is fixed. So if you think about that shape, Now, even if I do pour it, its shape is going to change, but it's still the same volume of liquid. It's not going to decrease in volume or increase to take up more space. Now, their particle spacing, they're still pretty close together. As we see, they're more random, less organized, but they are still relatively close, but they are further apart than in a solid. Their particle motion. Now, liquids start to move a little bit more. Now, instead of just vibrating in place like a solid would do, the particles in a liquid slide slightly past one another, but still maintaining generally that same organization. Their particle speed is faster than in a solid. So in a solid, it's going very slow. In a liquid, they're starting to speed up a little bit more. For that reason, their particle kinetic energy is also higher. It's a medium amount of kinetic energy. And finally, we have our gases. So if we think about a gas, gases don't have a fixed shape. They will simply take the shape of the container that they're placed in, and they will actually fill up that entire volume. So their particles are organized completely randomly, as you can see over in the image. Now their volume. They do not have a fixed volume either. If you put a gas into a container, that gas will actually separate to fill the entire volume of that container, meaning that its volume actually increases. So they do not have a fixed volume like the other two states of matter. Their particle spacing, again, as you can see in the image, they are very, very far apart. Their motion. Now we're looking at particles that are constantly moving at random and very, very far distances. So if you could think about all of these little particles bouncing from one side of the container to another and simply moving at complete random, that is how the particles of a gas behave. They also are traveling at a very, very, very high speed. So if we were really to look at it, it would look more like this. So they are traveling randomly in many, many different directions at a very high speed. Because of that, again, they also have a very high amount of kinetic energy. So these are our three states of matter. Things that we want to keep in mind again are the organization and spacing of those particles, the motion or how those particles move, the speed of those particles' movement, and the kinetic energy of those particles. As we saw, as we move from a solid to a liquid to a gas, spacing increases, speed increases, motion increases, and most importantly, kinetic energy increases as well.